All right, we'll start in a few minutes, guys. How many we got? 7. All right. Just to show you the chat feature over here. Today, instead of sending them via Remind, send them via that so we can see your questions. And it's more in real time. Oh, The Shadow. Didn't you watch this morning too? Whoever that is. I mean, there's nothing wrong with watching twice. We'll wait a couple more minutes. If you got questions, I was there. Oh, that's right. Yeah, you're sorry. You're in. Who's the Shadow? Then got it lowered down to 3. I have my best guess. Nobody else wants to talk? Is it 130? It's 129. We'll give it just a sec. Hi, I've been waiting to see my favorite pair of dog walkers walking outside today, but so far, no. Poor dog. He's probably all alone in his house. All right, if you got any homework questions, we'll get started now. If you got any homework questions, put them in the chat, put them in the remind. We will give you about a minute to get those into me. Sorry. My dog was really looking forward to somebody walking by today. He's been staring out the window like depressed. He's first off, we're home all day, which he loves because he gets all sorts of attention. But then, second, nobody has been outside walking their dog today for some reason. I think it's very depressing. He has literally nothing to bark at. Any questions? If not, we'll start. I texted out to you earlier today a new warm-up packet for SATs. If you'd go to page, I think it's 38 in there, page 38, and do 1 through 3. We'll continue to do problems just like we always did, 1 through 3, and then I will go through the answers with you. If I'm nice, I'll even send them to you. So again, open that up and work those first 3 problems. We will keep getting used to doing that to kind of keep things as normal as possible. And again, if you're just joining us, I was looking for any homework problems, but none so far. If not, go ahead and do those first 3. All right. Anybody need more time? All right. Let us try this bad boy out here. Let's see what the internet can do for us. Let's go for everybody go into the chat and put your answer in for none. Number one. Number one. I gotta get the answers up. All right. All right. Here are the answers to number one. It is. Everybody put their answer in. Good. Nope, nope, nope. Let's go down, down, down. Oh, the answer to number one, which is 2z plus 1 is equal to z. Answer to number one is be like boy. Good job. 2 for 2, the people that replied. Put your answer in for number two. Some of you, this is your favorite answer I give. That's a pretty big hint. Number two. Yep. Good job. C. Well, actually, hold on. C like kitty cat. C like kitty cat. If you put A for your answer, you forgot about the initial payment. So you have to. There are three. There's $60 initially, and then W payments of $30 each. How many are left? You just forgot about the 60. Number three. Put in your answers. Number three. Answers. Number three. The Shadow got A. Laying on two others. Number three. Zoe got C. All right, the answer for number three is be like boy. Now, if you missed any of them, I'm going to shoot you the answers in the chat here. There's a full explanation available at this here website for each one of them, for each one of the problems. Okay, now that we got you, any homework questions? Any homework questions? Any homework questions? Give you a few seconds more to take a peek over. If not, we'll just go straight to work here. Nobody? None. All right. Start the new lesson then. Let's just get smarter today. I did do a few problems. I think I did 2 and 4 in the video from the other class. If you want to watch that one, some of you I know are watching all of them because you're bored. All right, so new lesson, we're going to finish 6.4, and then we will do 6.5. 6.4, the second part is the radical transformations. In other words, given a radical, we're going to be able to describe the transformation, graph that bad boy. It's weird. It's been too dark before. Now it's too bright. All that sun outside. Well, kind of sun. It's really snow, but... All right, radical transformations, our parent function will be y is equal to the square root of x. Let's, of course, get, this one will have 4 critical points for us, so let's get some critical values in there. Oh, that's too dark now. Let's move it up one more. Let's try one more. There, let's see if that works. All right, our critical values for this, 0, 1, 4, 9 on our x. You, on your own, fill in the y values. All right, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is, you have to yell louder. You're not as close to me as you were before. Right, square root of 4 is 2. Square root of 9 is 3. Let's graph this bad boy. Let's talk about the domain and range of this bad boy. So 0, 0, 1, 1, 4, 2, 3, 4, 2, and then 9, 3. So we get this shape. It's still got a positive slope. It should be a little bit more like this. Yeah, there, we'll connect the dots. That's what it looks more like. Should be kind of like this, actually. Once it grows, it gets once it grows pretty quick from 0 to 1, and then it's pretty slow growth after that. This is our parent radical function. This is what they look like. Let's talk about the domain of a radical and the range of a radical. And then let's talk the exponential one we talked about yesterday. No, we'll talk about that at the end. That'll make more sense at the end. All right, domain. What's the smallest number you can substitute in for x and get an answer out? Well, why didn't I substitute any negative values in here? Right, I didn't substitute any because they would give us an imaginary answer out. So the smallest number you can substitute in and get an answer out is actually 0. Then what's the largest number I could substitute in? Well, I could keep that bad boy going forever. That's why there's that arrow over there. I could, the square root of 10 trillion, it has an answer. So we can go all the way up to infinity for that. Range. Well, smallest value I can get out is 0, and then it's going to continue to grow forever. So actually kind of odd. The domain and the range are equal to each other in this one. If you go back to the glory days of polynomials, we had a domain and range of negative infinity to infinity. except for quadratics, the domain was negative infinity to infinity, but then we did some work on what the range was based off where the vertex was, but this function has a domain and range 0 to infinity. Now, of course, if we transform it, left, right, up, down, that's going to change the domain and range. But for right now, the radical function, that's perfect. So let's talk about transforming them. And let's do it by example. Taking example number 1, we've got f of x is equal to the square root of x. We got g of x. Let's do nice or nasty. Nice or nasty. Let's do nice for the first one, times the square root of x minus 4 plus 1. Here's what I'd like you to do. Well, let's identify real quick. Let's give you a little bit. Of course, before the action of the function, and this function's action is the square root. Before that action is the inside of the function affects the x values. We did that calculator activity at the start of the year that talked about that. Y values are on the outside. So what I would like you to do real quick, tell me what are the transformations that occur to this bad boy to take it from the parent to g of x? On your marks, get set, math. Give you a couple more seconds. Write those bad boys down in your notes. All right, x minus 4, what's that going to do? 4 units to the, okay, come on, people. Your parents definitely didn't hear you on that one. 4 units to the right. Correct. 4 units to the right, because it's going to take every x value, move it 4 to the right. So kind of odd. Could we substitute 0 in and still get an answer out? No, we couldn't. If we substitute 0 and suddenly this is imaginary. So we need to move everything 4 units to the right before it starts. 4 units to the right before we could actually get a number out. What's the times 3 going to do? Vertical stretch by a factor of 3. Plus 1. What's that going to do? Yep, 1 up. So again, here are your transformations. Translate 4 units right, 1 unit up. Vertical stretch by a factor of 3. Stop and check up real quick. Questions on that? No, but this kind of weird. The other class I could barely keep up with the comments. This one's kind of quiet. Maybe everybody watching the morning class that's got a lot of questions. All right, so let's graph this bad boy. So let's take our points, and I apologize for being so. Oh, the fraction Is a fraction a stretch or compress? Good question. A fraction outside is going to be a compression. A fraction inside is going to be a stretch. And I was surprised there were no questions on number 4. If you look at the other class's video, number 4, it talks about one that's got a compression on it. But outside, compression, it's normal, compression. Inside, opposite, stretch. Let's take a look now at the graph of this bad boy. So, of course, we will start like we always do with our parent functions, 0, 1, 4, and 9. 0, 1, 2, and 3. And now let's go for this new one. And I will do this, but then I'm going to ask you guys to make the graph. I'm sure you're very capable of doing that. No reason not to start. And I'm very aware spring break starts after this class is over, so no small amount of pressure here. All right, so what does this do again? It translates everything 4 points to the right. So we're going to take this one and move it 4 to the right. That moves it to where? 4, good job. That moves this to where? 5. And let's pause for just a second. If we substitute 5 in, the first thing we're going to do is 5 minus 4. 5 minus 4 is, right, good job. 5 minus 4 is 1. So we're still taking the square root of 1, but now we have to move 4 to the right to do it. Move 4 to the right to 8, move 4 to the right, 13. Now the harder part. We're going to take our y values. We're going to vertically stretch them. We're going to take that distance between that and the x-axis and make it 3 times bigger. Then we're going to add 1. 0. 0 times 3 gives us 0. Plus 1 is 1. Move to the next one. 1. 1 times 3 is 3. Plus 1 is 4. 2 times 3 is 6. Plus 1 is 7. 3 times 3 is 9. Plus 1 is 10. Now note, let's talk about the domain and the range of this guy. The domain and range of this guy. Domain, what's the smallest value I could substitute now in and get an answer? Well, if I substitute in anything less than 4, it's going to give me what kind of number? Right, imaginary. So that's the smallest number I could substitute in and get an answer out. And of course, I can keep going up to infinity. Range, what's the smallest value I can get out? Well, that's when I substitute in. So I can go from 1 to infinity for the range on this bad boy. Give you a second. Questions on that? Don't forget, you send them to the remind, or you can send them via the chat feature. Amy? None? Okay. Oh, yeah, there we go. The domain is X and the range is Y. Correct. Yep. Domain is inputs, range is outputs. So domain is X, range is Y. Right. Any others? No, all right. So let's give you guys one. Example number 2. Let's go for nice or nasty. Let's go for f of x is equal to the square root of x. That's our parent. And g of x is equal to, I don't know. Let's go for it. Why not? 1/3, because we aren't afraid of fractions. Let's go for 1/2 x minus 3 plus 4. Give you guys a second. I want you to do 2 things. Dose things. Numero uno, tell me what the transformations are. Number 2, give me the places those 4 key points end up afterwards. And then ready, set, math. Give you a few more seconds. All right. So let's talk about this bad boy. So let's start on the inside. X minus 3 is going to do what? 3 to the right. Good job. 1/2 is going to do what? Horizontally do what? Right. Horizontally stretch it because it's on the inside. Remember, opposite inside by a factor of 2. Okay. That's what happens to our X values. Y values multiplied by 1/3 gives us a what? Horizontal compression by a factor of 1/3, which is going to some fractions, but let us not be scared. And then plus 4 is going to move 4 up. Good job. All right. So let's take our 4 key points, our x's, our square root of x's, and let's translate them to x 1/3. Okay. So we start out 0, 1, 4, 9, and let's figure out where those go first. So we're going to move 3 to the right. So 0, move it 3 to the right, gives us 3. Then we're going to multiply. We're going to stretch that distance out by a factor of 2. So that's going to give us what? 6, right. 3 to the right, 6, multiply by 2. 3 to the right, 3, 6. Now, stop and check up. No, we're okay with that. We're okay with that. All right. All right, do the next one. 1. Substitute in 1. 1 minus 4 is? Right, 3. 3. So we're going to move 3 to the right. So that moves us to 4, right? And we're going to stretch by 2. That gives us 8. Good job. 4. Move 3 to the right. That goes to 7. 7 times 2 gives me 14. 9. 9 minus 3, or 9, 3 to the right is 12. Then double it up to be 24. Stop and check up. Questions on that? Questions on that? All right, ready, set, let's go then. Now, our y values, 0, 1, 2, 3. Okay, we got multiplied by 1/3, add 4. 0, good news, 0 times 1/3 is? 0 plus 4 is? 4. 1, 1 times 1/3 is? 1/3. 1/3 plus 4/3 is 4 1/3, which is 13/3. 2 times 1/3 is 2/3, plus 4 is 4 2/3, which is what, 14 over 3 ish. 3, good news. 3 is an easy one. 3 times 1/3, yep, is 1. 1 plus 4 is 1 plus 4 is 5. Good job. Stop and check up. Questions on that? Why do we have to times the x by 3? We first have to add 3 and then multiply it by 2 because that's the operations that are happening. It's moving 3 to the right and then being horizontally stretched by a factor of 2. That's why you got to do it in that order. 3 to the right, then stretch it by a factor of 2. Let's go to domain and range real quick. Domain, what's the smallest number we could substitute in and get an answer out? Right, 6 to infinity. What's the range? The smallest y value we can get out is 4. 4 to infinity. That's as hard as those bad boys get. Questions on that? Okay, kind of odd. I'm going to give you your homework today, but I'm going to give it to you in 2 chunks. Here's the first chunk that addresses the end of Learning Target 6.4. It's actually out of your book today. No, cray. So I will send this out later today. I got a couple things to do this afternoon. We got a virtual staff meeting today. All right. Then we're going to do Learning Target 6.5. 6.5 is solving radical equations. 6.5, solving radical equations. There we go. Oh, yeah, finally, somebody walking their dog outside. They're absolutely crazy. I don't know what they're thinking. All right, now here's what we got. We got an extremely important vocab word, extraneous solutions. Extraneous solutions are solutions to an equation generated by algebra. Solutions to equations generated by algebra that do not solve the original problem. That do not solve the original problem. And you know, after all, that is what we're trying to do, is solve the original problem. It's kind of weird not being able to see anybody. It doesn't really know how long it takes to do stuff. All right, so let's take a look at an example problem. What should we do first? Let's look at this one. Let's look at example number 1. Let's go for x plus 1 is equal to, I don't know why I put parentheses around that, the square root of 7x plus 15. All right, let me ask you a question. What do you think you'd do first? Go ahead and type it in the chat. What should we do first with this bad boy? What should we do first with this bad boy? All right, I got Millie so far. Anybody else? Nobody else? Okay. Yeah, let's do what Millie said. Let's square both sides. Maybe she got a context clue by the parentheses. Maybe she just knew it off the top of her head. Maybe she's the only one that answered, so it doesn't matter. Square both sides. And now the easy part, the square root squared. Notice that takes us to 7x plus 15. If we square this side, let's distribute it out. We get x squared plus 2x plus 1. Now, here's the odd part. What's the degree of the equation right here? Good job, degree 1. How many solutions does the degree 1 equation have? Up to 1. Remember, it's up to, not guaranteed, up to 1. What's this now? A degree 2, which could have up to 2. All right, let's solve this bad boy, but that's how an extraneous solution is generated, when you increase the degree of, increase the degree of the complexity of it. So let's go away. We're really good at solving quadratics that are equal to 0. We really like leading coefficients to be positive. So let's move that all over to one side. So you got x squared minus 5x minus 14 is equal to 0. This is where we go back to our second unit. We could factor quadratic form, formula. And we got that. Does that factor? Oh, yes, it does. X minus 7, x, that's a bad x, x plus 2. So x equals 7, x equals negative 2. All right, so you're all chipper and excited moving on to the next one, or because your assignment's out of the book tonight, you're checking the back of the book. But you go back to the original equation. Let's check both answers. So let's check x is equal to 7 first to make sure it actually solves this. I did it again. Why did I do that? Ugh. All right, so check. So substitute in, we get 7 plus 1, that's equal to 8. Substitute in, 7 times 7 is 49. 49 plus 15 is 64. The square root of 64 is 8. Do we have to consider the plus or minus? No, we don't. Why? Because we did not introduce the square root to this equation. It was already in there. So 8 equals 8. So that checks out. Good news day. Let's check the other answer. Now, you know it's not going to work because this is degree 1, but let's show why it doesn't. So we're going to check x is equal to negative 2. So we get negative 2 plus 1. That should be equal to the square root of 7 times negative 2 plus 15. Oh, yeah, you can see what's going to happen. Negative 2 plus 1 is? Does the square root, could it possibly return negative 1 as an answer? No, that's not equal. So our only answer, x is equal to 7. Sole solution to that boy. Give you a second. Check on you guys. Questions on that so far? Questions on that so far? Not so far. Okay, hearing none. Let's go. We'll do one more. Do one more. What should we do with this bad boy? What should we do with this bad boy? Okay, x plus 30 to the 1/2 power is equal to x. I'd like you to try this bad. Oh, so our only answer is x equals 7 because the right side is degree 1. Correct, right. In fact, the original problem is degree 1. That's the original problem is degree 1, so it can only have up to one solution. It could actually have 0 as well, but a degree 1 cannot have 2 solutions. And here's another, just a visual way to see it. If you've got the left-hand side and the right-hand side are at most degree 1, how many times could they intersect? I mean, think, at most they're degree 1, so we know this is going to look like a square root, something like that, and this is going to be a straight line. How many times do they intersect? 1, right? Give you guys a second to try that bad boy out.
And I saw a shoebox in my closet.
And yeah, those are the next size shoes for you.
The next?
Yeah.
Mom got me early?
Yeah. We decided just in case it's hard to go get shoes. Okay.
Oh, you got it for the coronavirus.
Well, we didn't know about Corona at that time, but it worked out.
Well, I told you eating animals was weird. And you got prepared for what I said.
Right. You want to say hi to my class real quick?
What?
They're working on a problem. You want to say hi to them?
Hi, my daddy's class.
What are you excited for in the next few days?
Relaxing. Aren't you?
What are you going to do? Well, Daddy doesn't have to work the next few days. What do you want to do? Relax.
Oh.
Yeah?
High schoolers, are you sick of math thingy-majiggy?
Why? Millie says hi, Emily. She's the one that wants to do FaceTime appointments with you.
Oh. Wait, I asked her if she wanted to babysit.
Well, she can't babysit right now, but she might be able to talk to you and help you relax.
Who wouldn't?
I know. Who wouldn't think it's fun to talk to you? All right, let's finish this problem. Let's finish this break. What do we do to both sides first? Square both sides, right? Because we want to undo a square root. That gives us x plus 30 is equal to x squared. Finish this bad boy off. We really like quadratics that are equal to 0. You can hang out in my room. Is Ben sleeping? My son decided to wake up at 3 in the morning this morning. I don't know why or what he was thinking doing that, but now he's taking a nap. Factor it. 0 is equal to x plus, x minus 6. You're right. 0 is equal to x minus 6. X plus 5. Solve. X is equal to 6. X is equal to 5. Check. Which one should we check first? Right. That's a negative 5. We should check the negative first because I don't think it's going to work either. So we get negative 5 plus 30. 1/2 power is equal to negative 5. Is there any way a 1/2 power can return a negative? Nope. All right. Other side. X plus 30. 1/2 is equal to x. Let's check 6. So 6 plus 30 to the 1/2 power is equal to 6. The square root of 30 plus 6 is 36. What's the square root of 36? 6. So that works. So conveniently, our only answer that works is x equals 6. Now, worst case, let's go through. Is it possible both of them could work? No, because it's degree 1. Now, if the original problem is degree 2, of course they could both work. Is it possible neither one of them work? Yeah, it's possible there's no solution to this problem. So let me show you the last part of your homework to work on over break. Now, I realize there's been a couple struggles that have been made real for those of you that actually end up watching this today. Number 1, boys, can't really talk to them now. Got to stay 6 feet away, so there's no chance of being distracted by them. Number 2, drugs. Good luck getting somebody to deliver to your house right now. Like, forget about it. So you might as well get your math homework done. I don't see anything else or any other reason to. So let's get the work done. As you're copying that down, I will text this out. Maybe not right now. Maybe later today. Actually, maybe I can do it right now. I got a meeting later and I'm going to forget about it. Nope. Get all this paper recycled here. You're right. Good. Whoever said that, right? We want to recycle paper. The sooner we recycle it, the sooner it can become toilet paper. The sooner it becomes toilet paper, the sooner we stop flipping out about toilet paper in this crisis.
Toilet.
Boys are stupid anyways. Interesting.
Daddy, what happens if your students don't do homework? What happens?
I don't know.
Detention?
Well, they're stuck with their parents now, so I can't really give them detention. Oh, and then to submit homework, I made a folder in the Schoology page for this, for both 5th and 8th period. It'll say the assignment. Yesterday's assignment was 6.4. Today's assignment is 6.4, 6.5. Take a picture, upload it into those folders, and that would be terrific if you guys would do that, because that is much more organized, I've noticed already. I'm just waiting for this to upload real quick. I'll send you guys both parts of the assignment, and then we will, my parents can give me detention. Yeah, they can. What are they going to ground you, though? Yeah, it's a picture of 6.4 and submit it. Go into Schoology, click on Chapter 6. In there, there's a folder for each assignment for yesterday's and today's. When you're done, just throw it in there, please. Yeah, grounding. I didn't think about that. They give you detention. What do? Just send you to your room? Like you're stuck in the house anyways. That's, yeah. Got to think about that one. Yeah, Ben doesn't either. He's loving this. My dog, however, my dog is not loving this. Or my dog is loving this. He can't believe we're home. My cat is desperately trying to break out of one of the windows of my house so he can get away from all of us. He misses having the house to himself. Ella, can I ask you a favor? I have to actually take a conference call here in a little bit. I did number 4 on the first video I sent today with the other class. It just has a horizontal transformation in it, but that'll have that on there for you. Anybody else? Introverts are probably loving this. They don't have to go to school. It's going to change the whole high school experience for introverts. They don't have to interact with anybody. I think for some people, that's what they've dreamed high school was like. Anybody else? All right, guys, have a great break. I'll see you on the other side. I got a whole bunch of grades I got to put in there. I just need some time that my kids are sleeping to get away. And my wife's been working like 24 hours a day, so I haven't even really seen her. So as soon as I can get them in, I will. But kind of odd. I've been single parenting it here since this whole thing started. So we will see you guys on the other side of spring break. Have a wonderful break. Stay safe. Stay away from other people. Read some books, watch some videos, eat some popcorn, have virtual dates. Yeah. See ya.